Right. Question number 289. Revision tube number 4, question number 288. A person can see an object by keeping 25 centimeter away from the eye after wears the spectacle of 1.5D. Then power of the lens is 1 over f. This one consists with commercial sign convention. Exact minus sign for the lens, we have to apply sign convention for this focal length. But here, it is just 1.5 diopter. No, it's okay, right? Then find the near point of the defective eye. Let's see. Find the near point of the defective eye. This person can't be seen the object at 25 centimeter, but after wearing the spectacles, he is able to see the object of 25 centimeter, right? That's it. Then the light rays that are coming right here will form the image at a point behind the object. It is virtual one. This one served as the object to the eyelid to form the image on the retina. This is the corrected eye, no? This is called corrected eye, like this. Okay. Then this one is the image distance after keeping the object at 25 centimeter by the worn lens. This one is the wearing lens. This serves as the object to the first lens, will form the image on here. Now, this one is image distance when we apply lens formula for this one, right? When we apply lens formula for this one, this would be the image distance by considering the object position at least distance of distinct vision. Clear? Right. Then this is called previous investigation. We call this one near point of the defective eye. You are asked to find this one, then finding the focal length of this one, 1.5 equal 1 over f. F is 1 over 1.5, which means 2 over 3, 3 over 2. Focal length is 2 over 3 meters. Focal length is 200 over 3 centimeters, right? Then it is convex lens. So you are given this one plus, then commercial sign convention consists with minus sign. It could be convex lens, right? Then lens formula, 1 over V, 1 over U equals 1 over F. 1 over V, image distance to be found. 1 over U, it's 25 centimeter. This one, 1 over 200 over 3, sign convention minus as convex lens. Now simplify this one. 1 over V becomes 1 over 25 minus 3 over 200, right? This becomes plus, this one is minus. Common denominator 200. Here 8 minus 3, 1 over V. V becomes 200 over 5, no? 40 centimeter. This could be the location. This is the least distance of the defective eye. So Find the near point of the defective eye. Answer 40 centimeter, right? Complete the answer. Next, 290. Read the question carefully. The person can see long distance after wears the spectacles of 0.25 diopter. What is the far point of the defective eye? Person can see the distance object, long distance you can consider infinity long distance, right? Infinity long distance, right? Infinity long distance. Then ray diagram we can manage. This one is the observer's eye. Here we have concave lens. When the object is kept at infinity, parallel beam of light fallen on the lens, they are diverging from the point of the focus of the wound lens, concave lens, right here. This is called far point of the defective eye. Far point of the defective eye. So this is the arrangement of the ray diagram, right? Okay, then what is the far point of the defective eye? It is exactly focal point of this one. Or you have to apply lens formula by considering infinity long distance objective distance and forming the final image by the infinity object, not the final image, forming the first image by the infinity object at the far point of the defective eye. It serves as the object to the eye lens to form the image on the retina. Clear with the right. Then here, power of the lens is mentioned, no? P equal 1 over F. It is diverging lens, right? Exactly, power should be minus for the given one, 0.25, but it is not mentioned, then you should identify the name of the lens as concave lens without seeing the power of the lens, right? Okay, here we don't apply sign convention as it is not mentioned the sign convention. Here 0.25 power equals 1 over F. F becomes 1 over 0.5 is 1/4, right? Then focal length is 4 meters. Then you can apply, if you need, you can apply lens formula for the wound lens, for the concave lens. Like this, you can say 1 over V. V is the image distance. It should be found by keeping the object at infinity. Focal length is 4 meters, sign plus. Then V becomes plus 4 meters. In front of the eye, at the distance of 400 centimeter, will form the image. Then that point is the far point of the defective eye. Without having the spectacle, he can see clearly only 4-meter distance. Right, far away from the 4-meter distance, it is blurred one. They can see no matter, but closest two images, closest two objects won't be clearly separated, right? Then it would be the blurred one. කියන්නේ ඈත පේන්නේ නැහැ කියලා කවුරුවත් කියන්නේ නැහැ. පේනවා but not clear, right? කියන්නේ බස් එකක බෝඩ් එකක් වගේ එකක් ඈතදී කියව ගන්න ටිකක් අමාරු එක උඩක වගේ තියෙන. Okay. 291. Copy this one. 291. Find the minimum and maximum focal length of the defective eye, right, of the near point 4 centimeter, 40 centimeter, and the far point of 100 centimeter from the eye, right. Diameter of the eye is 2 centimeter. He can see a range, no? Near point 40, far point is 100, right. Here we have eye, near point. Here near point 40 centimeter. The near point image clearly seen, no? The objects that are kept at the near point can be clearly seen. Anyhow, this distance 2 centimeter. That won't be changed, no? This is 40 centimeter. So you can say 1 over V minus 1 over U equal 1 over F. 1 over V, 2 centimeter. Sign convention towards this side minus, backward plus, right? Okay. It's minus 1 over U. U is 40 centimeter. Sign plus equal 1 over F, focal length. This could be the maximum curvature one. When you keep the object closer to the eye, curvature of the eye should be maximum. Then focal length should be the minimum one. It's minimum one here. Then we have common denominator here, 40. 40 here, 2. That's 20 minus. Here minus 40 is 1. This is the minimum focal length. So minimum focal length becomes 40 divided by 21 centimeter. This could be the minimum one for the defective eye, right? Okay. And for the objective one, at far away position, here you are mentioned that value is 100 centimeter. If you keep the eye at a point of 100 centimeter, that is the farthest position that the person can clearly see, no? So light rays are coming right here, converging on here, forming the image on the retina. Here we have 100 centimeter. Then image anyhow should be the distance of 2 centimeter. Image definitely forming on the retina. Otherwise, that won't be seen. No? Yes, therefore, image distance exactly 2 centimeter, which is equal to the diameter of the eyeball. So 1 over V2 minus 1 over U, 100 plus, no need to sign the plus here, 1 over F to be found. This is the far away, farthest location of the person that can be seen. Now, then curvature is minimum, then focal length is largest one. This is the maximum focal length. So, common denominator here, 100. 100 is to 2, here 50, minus, it's 1, equal 1 over F max. Then maximum focal length becomes 100 divided by 51 centimeter. Right. Can you keep the final answer with 2 decimal places? This is 1.96 centimeter. Previous one, 1.90. Slightly different, right? 90 cent. That. Question number 291 completed. It's 292. Once, read the question 292. Find the minimum and maximum focal length of the eye if the distance of distinct vision is 25 centimeter and the diameter of the eyeball, mention one again 2 centimeter. the average value of the diameter of the human around 2.5 centimeter, but it is mentioned 2 centimeter. In past papers questions, several questions were mentioned 2.5 centimeters the diameter of the eyeball. Anyhow, no matter. Then they need the minimum and maximum focal length of the eye lens. Let's see when we consider maximum focal length, this point would be placed at infinity. That is the theory, right? This could be at infinity. What? Object. This object must be kept at infinity to take the maximum focal length of the healthy eye, which means normal eye. This is mentioned in the normal eye. 292, find the maximum focal length of eye lens and minimum focal length of eye lens if the least distance of distinct vision 25 and diameter 2 centimeters. So then we have to keep this object. This objective distance should be infinity long distance. So beam of light parallel to the principal axis. This is the incoming one. Right. Then object is kept at infinity. Now this is removed. So this is infinity. Then focal length of maximum one is equal to diameter of the eyeball, 2 centimeter minus. Minus is convex. It's the diameter of the eyeball. Clear? Right. And here, instead of this, for the minimum focal length, it must be 25 centimeter. Then this should be 25. This is the way of substitution, right? This is the minimum focal length ever. So, meet වඩා අඩු කරන්න බෑ focal length එක නේද? Common denominator here 50, 50 is to here 25 minus and minus 2 equal 1 over f minimum. So, you will have focal length of minimum value 50 over 27. Done. 50 over 27. It's 1.85 centimeter. This could be the minimum focal length. Done. Right. Next. Can we consider 293? A person can see infinity object clearly without using a spectacle when he is using a simple microscope to see the clear image. Using a simple microscope to see the clear image. Now, this is the simple microscope to see the clear image. For the simple microscope, Darone, first of all, you have to remember, object must be kept within the focus, right? In between the optical center and the focus. Here must be the location of the object. Can we read the next part? Otherwise, normal adjustment is not operated, no? Yes. So, then and able to see only keeping the object in between 10 and 12 centimeter, but nowhere else. When you keep the object in between 10 and 12, 10 and 12, we have to keep the object 10 and 12, right? 10 and 12 to see the image, but nowhere else. What will be the least distance of distinct vision of this person? Then the image must be formed right here. This should be the location of the image right here. Then according to the database, this should be 10 centimeter, no? This is 10 centimeter and focal length must be 12 centimeter. Reason, we have to keep the object within the focus. So two data mentioned here. Then if you keep the object 12 and 10, you can change the location of the object from here to here to have the image like this. To have the image should be formed on the least distance of distinct vision. This is the observed one by the unaided eye. Now you are keeping your eye right here. Then can we copy like this? This is the location of the observer side. Assume these two are contacted with each other, right? Assuming මේ දෙක අතර gap එක අපි ගණන් හදද්දී neglect කරනවා පුතා, right? Okay. Then both the eye lens and the lens of the simple microscope right here. Then this one will form the image. This one will form the image of this one. At here, this serves as the least distance of distinct vision for the eye. Then image is formed on the retina right here. This is formed on here, right, like this. If this is H dash, this should also be H dash. Size will be definitely changed for the H double dash, right? Okay. Image of this one will be formed on the retina. Then this serves as the object to the lens by subjecting least distance of distinct vision. Then this space is negligibly small. So this is D. Done? Right. Then you should understand about the question. When you keep the object in between 12 and 10, in between 12 and 10, but nowhere else, keeping the object to see the clear image on the retina. To have the image on the eye, on the retina, you must keep the object within here and here. Then we can say one distance is objective distance, the mentioned other one is focal length. Focal length must be 12. Then those two values won't be interchangeable. If this is 12, if the objective distance is 12, focal length will be within the object and the lens optical center. Then object is light behind the focus, then real image will be formed at the other side. That is not the correct arrangement of simple microscope normal adjustment, right? Then definitely object must be kept within the focus, then the large distance should be the focal length, short distance should be the objective distance. Then apply lens formula 1 over V, V should be found 1 over U, U is 10, focal length is 12, should be minus 1 over V equate 1 over 12 minus plus 1 over 10. It's 12, 10, 60, no? 60, 12, 5 minus 5 plus here 6, 1 over V. Then V becomes 60 centimeter. He has defective eye, no? 60 centimeter is the image location. This should be the focusing point of this one, eye, as the least distance of distinct vision. Is that clear, brother? Right. Then answer is 60 centimeter. Okay. Question 294. The best viewing point of the replaced eye of the person is 10 meter from the eye. Replaced eye, no? After getting surgery, eye is replaced 10 meter for the eye. Find the type of the focal length of the worn lens by the person to see 25 centimeter. Let's see, it is replaced one. But after getting the surgery, the curvature of the eye lens won't be changed, no? You are given the best viewing after replacing the eye lens right here. Best viewing point is, the best viewing point is 10 meter. Then you have to keep the object at 10-meter distance to clearly form the image on the retina after replacement of the eye lens. Is it clear, Buddha? After the replacement of the eye lens is removed and another artificial one is replaced. No? That replaced lens is focusing for the farthest object of 10 meter. ඒ කියන්නේ යාට 10යි ඇහැයි අතර තියෙන ඒවා අපැහැදිලි වෙන්න ඕන. හරි. 10 meter is the best viewing point. එහෙනම් we have to use the spectacle. මොකටද? When you are looking 25 centimeter like this, clearly understand the situation, right? Understanding is the best one. ගානට උත්තරේ ගන්න එකට වඩා වැදගත් වෙන්නේ අපි මේ ගාන ඇතුලේ තියෙන ඒගොල්ලෝ අපිට කියන කතාව කියව ගන්න එක. හරි? එහෙනම් මේක තමයි දැන් මේක ඔළුවේ තියාගන්න. The eye is operating for the object lied at 10-meter distance, right? Now, you have to use, we have to manage the short distance, no? We have to manage the short distance. ළඟ තැනක් බලන්න ඕනේ. එහෙනම් we must use convex lens. We all should know this one today. These are very simple theory. Convex lens. Then you can keep the object 25 centimeter. This is your book, reading book. Right, book is kept at 25 centimeter. Then what will happen? This serves as the object of this one and will form the image. This is the objective distance. It will be form the image at 10-meter distance. 10-meter distance. This serves as the object to the eye lens. Then this is constructed one. It's the virtual magnified image, and then it will be formed on the retina like this. Then when you apply 1 over V, 1 over U equal 1 over F, image distance for the wand lens should be 10 meters, 1000 centimeters, minus 1 over U, 25 centimeters, you have to find focal length. So they compared with 1 over 25, 1 over 1000, negligibly small, right? You can remove this one, then keep the final answer about 25 centimeter. But when you simplify this one, it's 1000 common denominator. Here 1 minus 25 of 1000 is just 40, no? Then it becomes 1000 over 40. 1000 over 39, right? 1000 over 39. Then we have 25.64. No? Exact answer 25.64 centimeters. Today, if this is MCQ question, the most probable answer is this one, right? මේක තිය උත්තරේට 25.64 තියෙන එකක් නැහැ. Anyhow, correct answer is this one, not this one, right? Okay. Can we complete this one? Right, next one, 295. The diameter of the eye lens is, it should be 2.5 centimeters. Diameter of the eyeball is 2.5 centimeter. The power of the defective eye lens is 50 diopter. Power of the defective eye, this one, right? 50 diopter. 50 diopter, which means a mentioned value. Find the type and the power of the lens needed to see the distance object. Type, distance, definitely. It's a concave one. To see the infinity object, right? To see the infinity long distance object. So, then Pute, when you consider these two together, right? When you consider these two lenses as a combined lens, it's a kind of convex, no? This is the combined lens. Let it like this. This is the combined lens, right? Here we have eye. When you keep the object parallel beam of light, when you keep the object at infinity, parallel beam of light is fallen like this and then converging on the retina. No? Then this is the focal length of the combined lens. This should be the focal length of the combined lens. Then you can find the power of that combined lens. How? 1 over f. F is 2.5 centi 10 to the power minus 2. Then power becomes 100 over 2.5. Can we apply sign convention too? This is the commercial sign convention. Exact minus sign available here. And finally, light rays should be converged on here. Then compound lens should be a convex one. Then again another minus sign available. Then power becomes plus. It's 40 diopter. This is the power of the combined lens. Then power equal P1 plus P2, considering those two. Then power of the combination 40, and it could be positive 1. Positive power of the combined lens represents convex lens. Here 40 equal P1. P1 is the concave lens, unknown one, plus here 50, it is convex lens for the eye lens. Then P becomes 10 minus. Minus means concave. Right, this could be the final answer. Right, can you manage your answer with that? Done, right? Okay. (296). The near point of defective eye is 50 centimeter. Find the focal length needed to see the object 25 centimeter if the lens is worn by 1 centimeter in front of the eye lens. By 1 centimeter from in front of the eye lens. Okay. (296). This one is the eye lens. Right. Using the convex lens right here. After that, you have to keep the object at 25 centimeters. It serves as the object to the worn lens. This could be 25. Right? Object is kept here in front of the eye lens at a point of distance 25, right? Okay, then forming the image at a point of distance exactly 50 centimeter from the eye lens, right? That's the point. From the eye lens, it could be 50 centimeter. That's from the eye lens. $50 centimeter. Then from here to here, image distance should be 49 centimeter. As it is mentioned, this gap is 1 centimeter. Done. This is the arrangement of the ray diagram for the question. Now you are asked to find the focal length of the lens. Find the focal length of the lens. Focal length of the lens. 1 over V, 1 over U equal 1 over F. 1 over V should be 49 minus plus, right? 1 over U 25 equal 1 over F to be found. Right, then F becomes 49 into 25. 25 minus 49, right? Simplify the answer. About 51 centimeter. Right. Okay, let's see the next session. It's revision number 3, part D, heat discussion, right? Okay. Thermometers. First session of heat, no? Right. Then we are going to start the applications of heat one by one, starting from thermometers, right? Okay, read the session first. It's 297. What is mean by thermometric property of a thermometer? Thermometric property, when we consider mercury glass thermometer like this, when we consider mercury glass thermometer right here, assuming this glass bulb is completely filled by mercury at 0 degrees Celsius. When you supply heat to increase the temperature by just 1 degree Celsius, the mercury column is rising through the capillary tube like this until the location of 1 degree Celsius. Then the property of which that is response to, the property of which that is completely response to the thermometer reading, and also called the property of which that is changed with the temperature, the property of which that is changed with the temperature, that is called thermometric property. So thermometric property of the thermometer can we write first? 297. The property of which that is changed with the temperature, property of which that is changed with the temperature, property of which that is changed with the temperature is called thermometric property. 298. Write the thermometric property of the following thermometers. First one, mercury in glass thermometer. Expansion of mercury column. A, mercury glass thermometer, expansion of mercury column. Write down. Expansion of mercury column. B, alcohol in glass thermometer, same as mercury glass thermometer, expansion of alcohol column. Expansion of alcohol column. C, constant volume gas thermometer. Then you have to say that the pressure, don't write, the pressure of a constant volume of near ideal gas, or at least you have to say constant volume change in pressure. Pressure is the thermometric property of a constant volume, right? Constant volume. Write down. Pressure of a constant volume of the gas in the glass bulb. Pressure of a constant volume of the gas in the glass bulb. Next one, thermocouple. Electromotive force of both the ends. Electromotive force of both the ends of the constant wire. Or manganese wire, right? Okay. Thermistor. Resistance. Thermistor. Resistance. Okay. Explain the followings. 299. The sensitivity increases when the capillary bore radius is decrease of liquid in glass thermometer. Capillary bore radius is decreased like this. Here we have a thermometer with the small capillary bore radius. Then we are going to manage same size of glass bulb, right? This is wider one. This is narrow, this is wider. Same size of volume of mercury bulb. Let 0 degree Celsius at here. Let 0 degree Celsius at here. Then we all know change in volume of the apparent expansion of glass bulb. We can say that one is V1 gamma R delta theta, right? Then gamma R, mercury remains same. Temperature difference from 0 degree Celsius to 1 degree Celsius, right here. 1 degree Celsius remains same, then this profile remains same, then initial volume also same, VV, let this one V, then V2 minus V1 is a constant value, V1 gamma R delta theta. For 1 degree Celsius, both are common. For both common, this one, relative expansivity of mercury, it is a constant value, right? And initial volume, these two having same volume. So we have this value constant, which means increase of volume means area cross section into related height, right? AH is a constant value. Then you can say height of the mercury column indirectly proportional to area. This area A1, this area A2. Then area A1 smaller than A2, then rise of the mercury column H1 larger than H2. If area is large, height is low. If area is low, height is large. Then this one is having high sensitivity than this one, right? Anyhow, this volume and this volume getting same, right? As area is large, rise of the liquid column will be low, right? Can we copy this one first? Okay, then say if the capillary bore radius is reduced, if the capillary bore radius is reduced, if the capillary bore radius is reduced, rise of the liquid column will be high. Rise of the liquid column will be high. Rise of the liquid column will be high. Rising is high. Then sensitivity is also high. Sensitivity is also high. Okay. Question 300. The sensitivity can be increased when the radius of the glass bulb is increased. If you increase the glass bulb, volume of the glass bulb is increased, right? To compare those two thermometers, we should manage the same capillary bore radius. The comparison take place by considering the other physical quantity remain unchanged, right? By changing both, we don't understand the exact variation of each thermometer, right? Okay. Assuming mercury column lied at here at 0 degrees Celsius. Here we have large volume compared with this one. Okay, then same as previous, we can say this one is the equation. This is written AH equal V1 gamma R delta theta. Exactly this one common for both the cases as rise of the mercury column by 1 degree. So area or cross section of both remains same. Area remains same. Then you can say H directly proportional to V naught, initial volume. Now, initial volume of the first bulb larger than second bulb, then it is proportional, directly proportional. Then you can say represented height by this one, let it H1 and this one H2. Then H1 greater than H2. Then you have to say, if we have large volume of the mercury bulb, amount of initial volume of mercury column, initial volume of work mercury is large. Initial volume, if it is large, expansion should also be large. Expansion large, then rise of the mercury column should also be large. Can you manage this one first? Right. It's better to write here. As the initial volume, as the initial volume is dependent for the rise of the mercury column. Depending for the rise of the mercury column. This one. Depending for the rise of the mercury column. The large mercury bulb should have high sensitivity. High sensitivity. Right. Okay, right. Next one, 301. The accuracy can be decreased by reducing the glass bulb of the liquid in glass thermometer. Accuracy can be, can we rearrange that term for that? Accuracy can be increased. Accuracy can be increased by reducing the volume of the glass bulb. Can you rearrange the question? Accuracy increased by reducing the volume of the glass bulb, like this. Right, let's see. Here we have a thermometer with the large volume of glass bulb. Here we have another thermometer with the small volume of glass bulb. This is large volume, this is small volume. Today, when this one is exposed to a certain surrounding with high temperature, heat is absorbed, right? This is the amount of heat is absorbed by this thermometer. Lamine heat absorption, we can write M, specific heat capacity into temperature difference. You can see now, temperature let the variation from 0 degrees Celsius to 1 degree for both the cases, right? For both the cases, same temperature difference, right? And specific heat capacity, mercury remains same. Then you can say amount of heat absorption will be directly proportional to mass of the material at here. You can see now the mass of this material portion is larger than mass of this material portion, right? M2. Then you can say amount of heat absorption delta H1, here delta H2, amount of heat absorption by this mercury material, you can see now greater one is the large bulb. If large amount of heat is absorbed to register the reading, both are registering just 1 degree Celsius, right here. 1 degree Celsius registration, right? Both are registering the temperature by just 1 degree Celsius. Clear with that? Yes. Then amount of heat, same temperature variation, but amount of heat absorption by large mercury bulb is large. Then temperature of the surrounding, which means presence of energy after absorbing heat by the thermometer at the surrounding is low. Presence of heat at the surrounding after taking the heat by the thermometer is low, which means before entering the thermometer, available heat may be larger than the rest of the heat after completely immersing the thermometer in the given condition. Then put the temperature or heat amount at the surrounding decreases. That is called low accuracy of the thermometer. Clear? Yes. Then glass bulb should be much small as possible to apply small amount of heat to register a reading. Clear? Right. Write down next line. Copy this one first. Okay, write down. When the volume of the glass bulb is large, when the volume of the glass bulb is large, when the amount of when the volume of the glass bulb is large, the amount of heat absorption, the amount of heat absorption, amount of heat absorption amount of heat absorption by the large mercury bulb is also large. Is also large. Then rest of heat at the surrounding, rest of heat at the surrounding will be low before entering the thermometer. Before entering the thermometer. Before entering the thermometer. Clear? Right. Before entering the thermometer. Then the amount of heat at the surrounding decreases. Amount of heat at the surrounding decreases. Therefore, accuracy of the thermometer decreases. Accuracy of the thermometer decreases. Right. 302. Read the question next. Three hundred and two. Accuracy of reading. Underline accuracy of reading. Accuracy of reading is related with the percentage fractional error of the reading. If you can measure large reading as the thermometer reading, percentage fractional error is low, then accuracy of the reading will be high. If the percentage fractional error if the percentage fractional error is low, accuracy is high. Accuracy is high. If the percentage fractional error is high, accuracy is low. Reading accuracy, not the accuracy of the thermometer. But the sensitivity, accuracy of thermometer, accuracy of reading of the thermometer, completely different three factors, right? Okay, then if you can measure large length for 1 degree Celsius or the unit temperature variation, percentage fractional error of height measurement will be low. Then it is called accuracy of the reading. Accuracy of the reading is high, right? Okay. Can we copy this one? 302. Okay. If the sensitivity is high, write down. If the sensitivity is high, 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 percentage fractional error of height measurement, percentage fractional error of the height measurement will be low. Percentage fractional error of the height measurement will be low. Then accuracy of the reading becomes high. Then the accuracy of the reading becomes high. Right. Next. Explain the validity of the following statements. Question 303. Right. Let's see. 303. Sensitivity of mercury glass thermometer can be increased by increasing the length of the capillary tube of the thermometer. It is not valid one. Wrong statement. First of all, write wrong statement. Why? Sensitivity of the mercury glass thermometer won't be depend on the length of the stem of the thermometer. Sensitivity depending to the amount of rise of mercury column through the capillary tube. To achieve this sensitivity depending on two factors. First one, area cross section and volume of the glass bulb. First one, can we write? Sensitivity depend on first one, sensitivity depend on Roman 1, Roman 1, cross-sectional area of the capillary bore. Second one, volume of the glass bulb. Okay, 304. Thermistor is the thermometer, can be easily made in the lab, in a lab, if the materials are given. Wrong. Write down wrong statement. Easily made one is thermocouple. It is just a wire. Thermocouple is the easily making one, as it is just a wire. This is hot end. This is cool end. Here we have high amount of heat. Heat transferred by dragging the free electrons. Electrons are dragging from here to here. Then this becomes negative terminal. This becomes positive terminal. Then there is a potential difference, which is called electromotive force in between both the terminals. It is measured by using a galvanometer like this. This is the simply making one, right? Okay. Note down. Thermistor is the thermometer can be easily made in the lab. It's wrong. Say it wrong. 304. Next, write down. Easily making one is thermocouple. Easily making one is thermocouple. Easily making one is thermocouple. Right, 305. If you need, you can copy this one too, right? 305. Thermometric property should be a continuous function. Yes, it is a valid statement. Say yes. Thermometric property should be a continuous function. If this one is the thermometer, here we have glass bulb. When you increase the temperature gradually, the rise of the mercury column should also be a constant one, continuous one. Not the constant one, continuous one, right? As well, continuous and constant variation should be arranged if the heat is supplied with the constant rate. Then continuously, this variation of temperature should be indicated if the heat is continuously supplied, right? If the heat is continuously supplied, this variation must be a constant rate, must be a continuous one. Otherwise, thermometer reading won't be exactly identified as the temperature of the surrounding, right? Then it is valid. Say 305, you have to write. It is valid statement. Explain. To have the continuous reading, to have continuous variation of thermometer reading, the variation of thermometric property should be a continuous one. Okay, 306. Thermometric property should be the only function with the thermometer. Thermometric property should be the only function. Yes. Why? If this is the thermometer, right, it should be responsed. This one should be responsed only for the heat or only for the temperature, right? It won't be changed with external pressure or variation of humidity, especially variation of pressure. This one won't be having the responsible one. It won't be responded. This thermometric property won't be responded to the other physical quantity that is varied in the surrounding. Surrounding means if this is immersed in water, now we are going to increase the temperature of water, then only the change of temperature is the responsible one to detect a reading. But for the variation of pressure or any kind of other stuff, which means another different kind of physical quantity, won't be subjected to change the thermometric property. Clear? Right. Write down next one. Only function. Right. Yes. Say yes first and write down. It won't be changed. It won't be changed to another physical quantity, to the other physical quantity. It won't be changed to the other physical quantity such as pressure at the surrounding. Right. Next, 307. Thermometer should be the linear function. It's better to write with a thermometric property, right? Not thermometer. Thermometric property should be the linear function with the temperature. With the linear function. Thermometric property should be the linear function with the temperature. Can we manage? Right, let's see. Here we have a thermometer with uniform capillary bore radius, right? This is the newly made one with uniform capillary bore radius, right, Pudha? This is the uniform capillary bore radius. Then, when the temperature is increased by 5 degrees Celsius from 0, assume change of volume. Here, 5 degrees Celsius, change of volume of the mercury column take place the height of 5 centimeter. Assuming, right? For another 5 degrees Celsius, if it is expand by 7 centimeter, if it is expand by 7 centimeter, that is called the non-uniform variation or non-uniform expansion of mercury column. Then Pute, we have a doubt. Why? If it is calibrated 1 centimeter for 1 degree Celsius, after passes 5 degrees Celsius, we have to rearrange the calibration according to this variation. It is hard case for the calibration, but it can be calibrated, no? Even though the expansion is different, calibration can be rearranged according to the expansion of the mercury column. According to the variation, we can rearrange the calibration of the thermometer. Or we can change the area cross-section to have the uniform calibration. That is also okay. Then Pute, this variation is not a must one. What? Thermometric property should be a linear function. If so, that is better. But put in no liquid or no thermometric property that is varied with the linear function. That is the problem, right? Okay, nearly mercury column will have linear function in between minus 18 degrees Celsius to 110 like that, right? But when we have very low temperature as well, very large temperature such as 150, 200 like that, or minus 50, minus 30, minus 20 like that, before the melting, before the freezing point of mercury and before the vaporization condition, which means the boiling point of mercury, we don't have exact variation, constant variation of mercury expansion, right? Therefore, it's better to use the rearrangement of the calibration. Calibration changes according to the variation of mercury column. Then thermometric property should be, right? Then you have to say it is not essential. Write down, this is not essential. This is not essential. Then the calibration can be rearranged. Calibration can be rearranged. Calibration can be rearranged according to the variation of mercury column. According to the variation of mercury column. Right. To take an idea, it's better to copy this kind of one, like here, 10 degrees Celsius. 10 degrees Celsius, done. Right. That's better, no? Okay. Right. Read the question 308. Okay, let's see another statement we have. When the temperature of hot liquid is measured by thermocouple and mercury glass thermometer, you are given two thermometers, no? Right, this one clear? 308. Measuring the temperature of a liquid. If this one is the liquid, if this is hot or cool temperature, thermocouple contacted like this is room temperature. This is hot liquid. Then after registering the reading of galvanometer in the thermocouple, we can calculate the corresponding temperature by considering this equation, no? By using this one, we can calculate the corresponding reading according to the Celsius scale. And this one is the thermometer, which is dipped in mercury column, which is dipped in the liquid, right? Certain liquid, right here. This is the temperature of 50 degrees Celsius. This is the temperature of 50 degrees Celsius. So here, both the contacted points of thermocouple and mercury glass thermometer clearly contacted with the surrounding, right? Therefore, the reading of this and this should be same. As well, this thermometer is perfectly contacted with the liquid. This one also perfectly contacted with the liquid. Then we don't exactly identify which one is the most accurate one, right? By seeing like this, that both may have the same temperature, that we can assume, right? But the doubt is this one. If you are given this kind of mercury droplet, such a small mercury droplet is contacted with hot region. This is hot mercury droplet. To measure this temperature, you are given thermometer. Sorry, you are given thermocouple, right? Then it reads a thermometer read. This one, this is mercury droplet. Mercury droplet, right? Hot one. Hot mercury droplet, right? Okay. Now you are given the above thermometer, this one, to measure the temperature of this mercury droplet, like this. This mercury droplet is this one, right? Okay, then you can see now thermometer, mercury glass thermometer is not exactly covered by the situation where the temperature should be measured. The surrounding is not completely covered. Surrounding means the situation where the temperature is measured, no, that is not completely covered through the thermometer. Therefore, this temperature may be less valued, like 45 degrees Celsius. If this is 50, this may have perfect temperature. That would be the reason for such a statement, right? Okay, statement mentioned, the thermocouple reads higher value than the mercury glass thermometer. එහෙම වෙන්න නම් පුදා liquid කියලා දීලා තියෙනවානේ. When the temperature of hot liquid is measured, no, then hot liquid consists with low volume. That's it, right? Okay, then can we copy this one? Here we have two temperatures same, right? But this one is the different one. Reason that is not perfectly contacted. That's the reason. Otherwise, Pute, we don't exactly identify which one. Whether which one is the correct one, which one is the accurate one, which one is the perfect one. We don't identify by seeing the names thermocouple and mercury glass thermometer, right? Okay, both are having different kind of accuracies, right? Okay, copy this one. Okay, right. Then write down mercury glass thermometer, glass bulb of mercury glass thermometer, glass bulb of mercury glass thermometer, mercury bulb of the glass of the mercury bulb thermometer may not be perfectly contacted, may not be perfectly contacted with the given liquid. With the given liquid, then 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 the registered reading of mercury glass thermometer may be less. Registered reading of mercury glass thermometer is maybe less, right?